All righty, that should be enough. That first paragraph is basically explaining the entire basis of our economy. You have money. It is not the 1920s. You are not stuffing your money into a mattress. You take your money to a bank. Well, not everybody. The vast majority of Canadians have bank accounts. They put their money in the bank. We will use one bank as an example because I do not want to continue to say 5 different banks or say all their names. You take your money to the CIBC. You get a paycheck, you go to the bank, you put it in the account. Is that bank machine, that bank branch that you go to, is it like the piggy bank you had in your room when you were a kid? No, it is not. It is not chock full of cash that you can pull the plug out of the thing's butt and take out the money that you want. The cash is not there. All right? All of the Canadian banks, all the CIBCs have access to your money. Now, you might not have a lot of money, but when you multiply your little bit of money by the millions and millions of people in Canada who have a little bit of money, you have millions and millions and millions of dollars. Do we all understand this? Right now, if any of you carried cash, but you're kids, so you don't, but if this was 20 years ago, before Interac was everywhere, you would all have some cash in your pockets. Not very much cash, but you would have some, right? Riley might have $3, Noah might have a 5, Emma might have 8 quarters. We couldn't do much of anything with it by ourselves, could we? But if we put all the money from all your pockets into a pile on my table in front of me, we could get some pizza or something, yeah? That's how banks work. Everybody puts money in the bank. That is your money. But you do not actually have it anymore. The bank has it. Now, what does the bank do with those millions and millions and millions and millions of dollars? They give it to other people. When I went to buy my house, I did not have a wallet with $300,000 in it. I did not have a bank account with $300,000 in it. I had a bank account with a little bit of money in it, which I gave to the bank, and they said, "You look like a good risk." And they gave me the rest of the money I needed to buy my house. Whose money was that? Yours. Everybody else's. Do you understand? So all the banks have access to a giant pile of money. All right? But it's not like Scrooge McDuck, right? You're not diving into the vault and swimming around in your gold coins. Do any of you even know who Scrooge McDuck is? Yes. Okay, just checking. It's not really like that. You own the money, but the bank is doing stuff with your money. You don't even know what the bank is doing with your money. Banks they own stuff you would never understand, right? When you go to Boston, if you go watch the Bruins play in Boston, they play at the TD Boston Garden. TD is Toronto Dominion. It's a Canadian bank. They own that building. So if you have a bank account at TD, technically, you are a part owner of where the Boston Bruins play hockey. Because they use your money to do whatever the hell they want. Now, since the bank couldn't do business without your money, they rent your money from you. And that rent is interest. If you give the bank $100, they have for you $100. If you put a $100 bill in the bank machine, you can get out another $100, but it is not that same $100 bill. Everybody understands this, yes? Because the bank is using other people's money for you to do your business, just like using other people's money for them to do their business. Everybody cool? The privilege of using your money to do what they want, they pay for, because that's the way the world works. If I want a hamburger, I go to McDonald's, I pay for it, I get a hamburger. The bank wants some money to go and build a dam in Djibouti, which is an actual country. I just like saying it because it's got the word booty in it. They want to build a dam in Djibouti. They take your money and go build that dam. Now, because you did not officially say, go ahead and build that dam in Djibouti, they pay you interest. They have bought your money from you. Everybody cool? All right, that's what we're going to talk about right now. There are two types of interest. Some of you already know this already, especially if you've taken Accounting 11. This is going to be extremely elementary for you. Have any of you taken accounting? Okay, this is going to be extremely elementary for you. So elementary, Christian, that some of the stuff I say you might be like, that's not what it's really like. But I don't care, because this is supposed to be a very basic introduction. Right? So, two types of interest. One is simple interest. Hey, guess what? It's simple. It's not hard to figure out. It's easy to work with. We are going to be talking about that first, because that is the first kind of interest that one will deal with which one will deal. So, you've read the second paragraph. Your bank account is most likely paying you simple interest, because simple interest is the least amount of money the bank can pay you. And the bank is in the business of making money, so why would they do something that would cost them more money? Everybody understands? Okay. Simple interest is typically applied to blah, 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 blah. All right, so here we go. Simple interest is a very simple formula. I. What do you think I stands for? Interest equals P R T. What math is happening between P and R and T? Multiply, because they're just lined up like that. P equals principal. It is not Mr. Como, but it is spelt the same way. Principal is the amount you start with. So if I put $100 in the bank, what is my principal? $100. Everybody cool? All right. R. Rate. Rate is a percentage. Now, in math class on your calculator, how will you enter that percentage? It is the rate divided by 100, or 0.xyz, however many decimals you need. Everybody cool? And T is time, and this is where it gets a little hazy, in years. Please underline years. And all you do is you put those three values together and you multiply them. Okay? Now, it's so simple, none of you are going to do what I'm about to do, but I'm going to suggest again that you do so. All you need to do is fill that in. So, P, R, T. Read the first question. What's the principal? $500. What's the rate? The rate is 2%. What will we calculate with? 0.02. That word annum is Latin. It means per year. I don't know why they don't want to say per year, but for some strange reason, we like to use Latin there. We also like to use Latin when we're talking about pay. If you get paid by the day, they don't say you're paid by the day. They say you're paid per diem. For some reason, we like to use Latin there, even though it's a dead language that nobody speaks anymore. For some strange reason, we insist on continuing to use the words. Don't ask me why. I am not a linguist. And the time is what? 1 year. Now, all you do is you fill it in. Interest equals 500 times 0.02 times 1, and you will get the answer. You just punch it into your calculator, you get the answer, and what is it? $10. Now, please observe, interest is $10. How much money is in your account at the end of the year? $510. $10 is interest. $500 is what you put in there. Everybody cool? So this question asks me, how much interest will I earn? It is $10. What is my total investment now? Still the 500 I put in, and I've earned $10 back. Everybody cool? All right. Look at the next question. Is my principal the same? Yes. Is my rate the same? Yes. Is my time the same? No. Because now it is 45 days. Time must be measured in what? Years. So what number do I put here? Right. 45 divided by 365. Because it is 45 365ths of the year. Now, does anything else change? Of course not. 500 times 0.02 times 45 365ths. And you punch that in and you get what? 501.22, isn't it?
I got 1, 2.
Don't you get 1 point?
Sorry, yeah, 2, 2. Sorry.
Yeah, well, it's 1.23, I thought.
Yeah.
All right. So your interest is 1.23. Everybody understand? It's that easy. Now, people talk about finance like it's difficult. It's not. Save money. Put it in a bank. Yeah, well, why do you think, which bank is that? Save money, live better. Is that Scotia? What? Oh, yeah, Walmart. Whatever. No, Scotiabank is you're richer than you think. Because you are richer than you think. Because if you put all your money in the bank, you automatically get more money. How many of you have heard that ad for Tangerine Bank? You put a little bit of money in the account. A year later, you've got a little bit more money. Then a year after that, you've got a little bit more money. Then a year after that, you've got a little bit more money. It's not difficult. People say, oh man, I don't know, money, oh, it's so hard to work with. Nah. Save it. Stop buying the iPhone XK9 1275 the second it comes out. Because it's the same damn phone as the iPhone 6 that you can get for nothing. What features do you use on your iPhone, Jorrit? Oh, I Snapchat. I take pictures. I text. Guess what I do with my G3? They're stupid. It's $1,000 for nothing. When you have a phone that does everything you need it to do, to buy a new phone is stupid. It is a waste of money. That is what I'm trying to say. That is why people in North America do not have any money. Because when they have something that works, it's not good enough. They need the next thing. Even though half the population of the world has never even made a phone call, let alone owned a smartphone. The point I'm trying to make is money is not complicated. Can you multiply 3 numbers? Yeah. Then you can be rich. It's that simple. All right. Let's have a look at the next question. You can read. What part of that can I fill in? The rate is what? 0.055. What else can I fill in? Which is what? 6 months, which is what? Which is 0.5, because it works out perfectly, because it's half a year. What else can I fill in? I, because I'm told I have $33 interest. Now, what's the formula I'm using? I equals PRT. Now, sometimes you get teachers that are like, you have to know that I equals PRT, just like the V equals DT thing, right? And they say, they're like, you have to know all 3 of them. You don't. You have to know one. And then you have to know how to do algebra. Do I need to be able to move this equation around right now by letters? Does it matter that P equals I over RT? Does that matter at all? Are you any less intelligent if you don't see that immediately? Of course not. Because what you can do and what you should do if you're ever in doubt is what your math teachers have been telling you forever. Fill in what you know. 33 equals P times 0.055 times 0.5. Solve that. What math is right there? Multiply. So you could multiply that. Then what are you going to do with the answer? Divide it. Could you divide right now? Sure. If you divide it by 0.055 times 0.5, and I divide it by 0.055 times 0.5, I'm going to end up with P by itself, yes? So there you go. What's the answer? How much should Heather invest? 1,000. Exactly. Cool in the gang. See how easy it is? And it doesn't get any more difficult. The formulas get busier, but it gets no more difficult. Everybody understand? Terrific. Read the next sentence while I set it up. In this sentence right here, what is the most important phrase? Do you think? Minimum monthly balance. Which means if I put my entire paycheck into my bank on the first of the month, if I'm paid by the month, and I put $5,000 in the bank, what am I going to do over the course of that month with that $5,000? Spend it. On what, David? Yeah, your iPhone 10 so you can't afford food. What are you really going to spend it on? I might spend it on Kool-Aid. You are right, David. I do have a bit of a thing for Kool-Aid. You've got me there. But David, unlike most North Americans, I will not spend $5,000 on something as frivolous as Kool-Aid. But I will spend some money on Kool-Aid at any given moment. So good guess. What am I going to do with that $5,000? I'm going to spend it. I'm going to spend it on food. I'm going to spend it on gas. I'm going to spend it on insurance. I'm going to spend it on my kids. I'm going to spend it on this, that, and the other thing. Yes? At the end of the month, I do not have $5,000 left, do I? So the bank pays me interest on the lowest amount that was in my account at any given moment. Why? Why do they use the lowest given amount? Partly because they don't want to pay you interest. But mostly, what was the very first thing we talked about? What is the bank doing with your money? They are conducting business. They are lending it to other people. They are lending it to corporations. Can they lend any of my $5,000 that I've already spent? No. The most they can lend out is the minimum amount that I had in my account over the course of that month. Yes? That is why minimum monthly balances exist. It's so the bank will always have capital, which is money, to do business with. Everybody understand? Now, you can have no money in your bank account. The bank will let you keep an account with no money in it. I don't care about that. But they're not going to pay you interest on it unless you have money in there for them to be able to use. Everybody got it? All right, so let's look at this situation. Over the course of this month, Erin is living her life. What does she do on April 1st? She deposits. That's a paycheck, yeah? How much did she have in the account already? So on March 30th, March 31st, there's 30 days in March, 31 days in March, 30 days, yeah. How much money's in her account? $250.31, yes? What did she do on April 1st? She deposited $850.25. A deposit is what? Credit? to her account or what we call debit to her account? I'm seeing if you guys know what these words actually mean. You all use a debit card. What does it mean? Money is taken away. That's what a debit is. You use your debit card to pay for things, right? Does the money come into or out of your account when you buy taquitos at 7-Eleven? Out. So that is a debit. Is this going in or out? In. So it is a credit, which means we add it. On April 1st, our good friend Aaron has $1,100.56. Yeah? Now, on April 10th, somehow she didn't need to spend any money for 9 days. Good, very good for her. On April 10th, she withdraws $375. What is that? That is a debit. So what do I do? Minus $375. Oop. And I get 5, 2, 725.56. Yes? Everybody cool? Okay, what does she do on April 15th? She does a deposit, which is what? Add 850.25. 1, carry the 1, 8, 5, 7, 1575.81 on April 15th. And what else does she do on April 15th? She does a very smart thing, and she withdraws $400. What do you think what could she be using that $400 for?
Car payment.
Sarah, groceries, right? Does she take any more money out of her account for the rest of the month? So she's going to take out that $400, and that's what she's going to live on for the month. When she runs out of $400, what's she going to do? Stop buying crap because she's out of money. Is she really out of money? No. But if she continues to use her debit card because she wants taquitos after that $400 is gone, what is going to happen to the money in her account? It is going to disappear. If you live on cash, is it possible to go broke? No, because you set a deadline for yourself. I have $400 to spend from April 15th to April 30th. I can't go over that because I'm only going to live on this cash budget. And you will also notice, psychologically, you stop buying garbage when there is actual cash in your hand and it is going away. I do this with my children. When we go on vacation, I used to say you can have $20 a day to spend, but I didn't give them a $20 bill. I would say, go get what you want, and I'll pay for it with my card. $20 disappeared in about 2 minutes. When I give them a $20 bill, at the end of the day, guess how much money they have left?
$15.
Usually $15 to $20, because all of a sudden, when the money actually has to leave their hands, all of a sudden it's a lot harder to spend. So, she does a very smart thing. She takes out $400 with which to spend and live on, and she's left with $1,175.81. Right? Okay. I want to know how much money is going to be in her account on May 1st. Well, it's a savings account, so we know it's simple interest. What is our P? $725.56. Why? Because that's the minimum monthly balance. What's the rate? So 3% is what the rate is on the poster in the bank. What's the rate that we actually can work with? 0.03. And what's the time? 1 month, which is what fraction of a year? 1/12. So what do? Interest equals P times rate times time. How much interest when you punch it into your calculator? $1.81. Where does that go? It gets added to there. Now, it doesn't seem like much, does it? But what did she have to do to earn that almost $2? Nothing. You know how they tell you there's no way to earn money without working? There is. Save it. Put it in a bank. Your money makes money automatically. That is how rich people live. I will give you an example of this. In the great country of Ecuador, which you all know I love, the banks will pay you 10% interest if you put a maximum of $25,000 into a bank. 10% of $25,000 is $2,500. There's 4 banks in Ecuador. So if you put $100,000 in Ecuadorian banks, you will be paid $10,000 a year for doing nothing but going to the bank and putting money in the bank. Guess how much it costs to live for a year in Ecuador? Well under $10,000 a year. Would you ever need to work? No. Why? Because your money works for you. Same thing here. If you win $1 million on the lottery and you put it into a regular bank account, like the bank account you have right now, CIBC, boop, 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 deposit 10000000000, stuff the envelope full of $1,000 bills, which we don't have anymore, but we used to. Put that in the bank. That $1 million will pay you $50,000 a year. That's a decent savings account rate. That's not even if you actually do some homework and find a good investment. That is your savings account rate. Everybody understand? I don't know about you, but I have a job. I get paid a pretty decent amount. I save a pretty decent amount twice a month from my paychecks. And I'm going to be paid for 35 years of my life. That's 70 times I've saved some money, yes? Each time I save that money earns more money. Evney. Checking accounts pay less interest because checking accounts are designed to have money going in and out. Savings accounts are designed for saving. Everybody understand? It is not difficult. And there will be questions in here that will blow your mind with how much money you can have if all you do is not spend it. Turn the page over, please. 193. Read. Ironically, ladies and gentlemen, compound interest is what the banks use when they give you money.
Crazy.
Yeah, surprise, surprise. But also, many investments pay in compound interest as well. You've read, you know what it means. I hope you know what it means.
What do you do for the starting principal?
We're going to do that right now. We're going to start with $1,000. $1,000. The interest is 8%, yes? That is very easy to do. What is 8% of $1,000? $80. So we're using it. So remember, our R, which is right here, is 0.08. Right? So our interest is $80. Yeah? Our new principal is now $1,080. Yes? Now, since it's simple interest, you've read in this, the principal is always the same. So what is going here? Still 1,000. We're still at 0.08. We earn another $80. So what does this become? 1,160. What's going here? 1,000. Another $80. 1,240. 1,000. Another $80. 1,320. 1,000. Another $80. And 1,400. What's the total amount of interest we earned? $400, which is always my final value, FV, minus my principal. And my new principal is $1,400. Not bad, hey? Grandma gave me $1,000 for my birthday. I put it in the bank and didn't spend it. 5 years later, I got $1,400. Pretty good. All I did was not spend. Right? All right. Now let's come over here and check out what happens if we compound it. So I still start with 1,000, yes? I still have a rate of 0.08, and I still earn $80 the first year, and now I have $1,080, okay? Now in compound interest, this is what Tangerine, the bank, is telling you. Your money earns some money. Then it earns a little more money. Tangerine is paying you compound interest, so this 1080 comes down here. It still multiplies by 0.8. What goes here? You've all got your calculators. What goes here? 86 point what? 4 exactly? 86.40. So this is now not 1,160. It's now 1,166.40. What goes here? 1,166.40 times 0.08. What goes here? $93.31. So this now becomes $1,259.71. What goes here? $1,259.71 times 0.08. What goes here? 100.78. Which is going to be $1,360.49, which now goes down here, times 0.08. What do I get here? 108.84, which gets me 3 carry the 1, 3 carry the 1, 9, 6, 1469.33. 70 extra free dollars. And all I did was sit. Now, imagine if you did that for the entirety of your working life. Grandma gave you $1,000 the day you were born. Put it in a bank, put it in an investment, never told you about it. What's going to happen? It's going to go very, very high, isn't it? Let me give you an example of this. I was recently in the bank doing some financial stuff, and the guy had a graph on his desk about what would have happened if you had $1,000 in the year 1900. So it would have been your great-grandparents. What that money is worth today, even after all the financial problems of the 20th century. How much do you think that $1,000 in 1900 was worth in 2015?
13 million.
Not quite. Way over $1 million. And that was only if you did conservative investing. You could make a buttload more in only 100 years. Now, obviously, you're not going to get that money because I'm not going to live to be 144. But who will benefit from that money? My kids, my grandkids, and so on and so on and so on. Right? We have to be smart not only with our planet, but with our money. If you're smart with your money, your family will always have it. Total interest earned, look at the difference when you add all this up. You don't need to add all this up because you know it equals 469.33 because that's what we were left over with when we started with 1,000. Easy peasy, yeah? Now, let's develop a mathematical model for compound interest. Remember, simple I equals PRT, yes? Because our principal never changes. Agreed? Right? Well, what happens in compound interest? Doesn't my principal change? It does, doesn't it? So I still start with a principal. And do I ever get less than that original 1,000? No, so I'm always going to be multiplying by original 1,000, aren't I? So principal times 1, yes? But I'm adding to it, correct? How much am I adding? What gets added every single time here in this scenario? I kept the original. What did I add? The interest, which was 0.08, yes? In this case. What is the interest in a general case? Well, it's rate, right? So I'm going to add my rate. Now, does that P multiply by the 1 and the rate? Yes. So I'm really taking my principal and I'm multiplying in this case by 1.08. Yes? Right? So that is where the interest comes in. Now, what's my years? How do I deal with the T? Do you think? Because I haven't shown you this. We're developing something. So in this case, we add 1,000 times 1 plus 0.08, and then the T, right? How do I write that T in? Am I multiplying it by 5? I'm not multiplying by 5, am I? Because it's growing every single year, yes? So if I was multiplying by 5, it would be a linear line, wouldn't it? Because it would go up the same amount every year, right? So I can't possibly be just multiplying by 5. What do I need in order to make that line not be straight? Because it's not straight, is it? It's not over 1 year up 80, over 1 up 80. It's over 1 up, what? A little bit more, a little bit less, what? A little bit more, then over 1 and up a little bit more, then over 1 and up a little bit more. What mathematical operation makes a graphed line do that? An exponent, right? Okay, how many times am I going to do that in this example? 5 times. So I got to go up to an exponent of 5. Everybody see why? Everybody understands? This one is a straight line. Over 1, up 80, over 1, up 80, over 1, up 80. This one, over 1, up a little, over 1, up a little bit more, over 1, up a little bit more, over 1, up a little bit more to make a curve. Everybody cool? All right, turn the page over. Not only does compound interest pay you interest on your interest, they will also increase the number of times they pay you interest. Simple interest pays you in fractions of a year. Compound interest will pay you depending on the agreement you have come to with the lending institution. So annually, there's that word again, annum. What does that mean? Yearly. So, number of compounds period per year, there's 1. Because you get your interest every year. Yeah? Okay. What if it's semi-annually? What's semi mean? What's a semicircle? Half a year. So how many times would you get paid your interest if it was semi-annually? Twice. What about quarterly? 4 times. What about monthly? 12 times. What about weekly? 52. What about daily? 365. All right. So, let's do the money. Here is where our calculation will happen. We've already worked it out that we're starting with $1,000. We will always get that $1,000, yes? And we will always add 0.08, yes? And if we are getting paid once a year for 5 years, how many times are we getting paid? 5. So this is our total. Now, how do we punch that into our calculator? You can punch it in just like you see it, even if you have a calculator that doesn't show the display. Punch in exactly what you see. 1,000 times, bracket, 1 plus 0.08, close brackets, exponent button 5. What do you get? Which is what we just did, right? 1,469.33, right? 1,469.33. That's that chart we just made, right? We all knew that was what was going to happen. All right, let's go to the next one. I still make my 1,000. I still pay 1. I still get my rate. But now, how many times do I get paid my money? 5 years, but it's twice a year. So what's my new exponent? 10. So what do I get for a total? $4,438, did you just say? No, stop a minute. Does that make sense to you? Knowing what you know about interest, which isn't very much yet, does that make sense to you? Oh, okay. Well, what is the answer when you do this? Somebody give me the right answer. It's not $4,000. What is it? 2,158.92. Now let's stop for a second and think about this. Our interest in this first question was $470, yes? Right? The interest here is $1,158. Does that make sense? It's in the bank for the same amount of time. Still at 8%. Does it make sense that we made $1,100 for the exact same amount of time invested? No. Even though you're being paid more interest, this makes no sense. It's too much, yes? So, You're intelligent young people. What is this rate? Per year. When are we getting paid? Twice a year. So what has to happen to that rate? It must divide by 2, right? So let's fix it up. Now punch it in and see what you get. Oh, you hit shift in there somewhere? QQ. Now, that makes more sense, right? 1,481, did you say, Isabel? That makes a little more sense, yeah? All right, so let's look at the third one. I still have my 1,000. I still have my 1. I still have my 0.08 per year, but I'm getting it how often now? Quarterly. So what must I divide that by? 4. And I'm still getting 5 years, but each year, how many times do I get the money? So what do I do here? Times 4. So punch that in. Show me what you get. Point 1,485.95. Okay. What's this one going to be? Still going to be 1,000. Still going to be 1 plus 0.08 divided by what now? 12 to what power? 5 times 12, which is 60. What's this next one going to be? 0.8 divided by 52 times 52 times 5, which is 260. And the last one, $1,500, $1,800, $1,830, right? Tell me the 3 answers. What? For which one? Oh, it's 1825, not 1830? Oh, of course it is. Yes, thank you. So, what was my interest in the first one? 14 what? Because I know it's going to be 14 something. 85. And then if I go weekly, 1491 point blah, I don't even care. And lastly, probably 1497. Sorry? Oh, made that little difference. Okay. Everybody cool? So now we know our formula, right? But it's slightly different because it's not going to give us... We never got the interest, did we? We got our new total, yes? So the formula for compound interest is A, which is your final amount. And what does it equal? Your principal times what? Look at what we just did 8 times. 1 plus our rate, but remember we had to divide our rate by something, yes? That changed every time, didn't it? So we got to give it a letter, don't we? The letter that we give it is N. N is the number of compound periods. And then we had to go to the t, but we had to multiply by what? 4, 4, 2, 2, 1, 1. We multiplied by n. Is everybody good? It's just a formula. So here we go. Chris invested $6,500 for 5 years, compounded semi-annually, and received that much interest. What was the rate? So let's fill out what we know. A equals P1 plus R over N to the Tn. What can I fill in there? Do I know my final amount? What is it? 6,500 plus my interest. Yes? $2,847.62. That's really hard to read. So that is 8,500, 9,300, 9,347.62. There's my A. What else do I know? Do I know my P? What was my principal? 6,500. Do I know my rate? No. Do I know my T? What is it? 5. Do I know my N? What is it? 2. So now I can figure it out, can't I? 9,347.62 equals 6,500 times 1 plus R over 2 times 10, right? Everyone agree? What's my job? Yeah, but don't I have it right here with the single variable? So what's my job when I have a single variable? Isolate the variable, yes? Let's start isolating. How do I get rid of that 6,500? Divide by 6,500. Right? So what's 9,347.62 divided by 6,500? 1.44, right? Equals, what's left over here? How do I get rid of something to the 10th power? How do I get rid of something to the square? Square root. So how do I get rid of something to the 10th power? The 10th root. Do we remember how to do that with our calculators? Yes, you just did it by accident, which is why you thought that you would earn $4,000. When you do the 10th root, what do you get here? It should be like 1.03 or something. Is it 1.04 equals 1 plus R over 2? How do I get rid of that R, or that 1? Subtract. So now I get 0.04 equals R over 2. How do I get rid of that? Divide by 2. Times 2. So 0.08 equals R. There's my rate. Please notice that all we did was algebra. Right? That is why people think that money is complicated. Because the regular Joe Schmo on the street can't do algebra. That's why people who do taxes charge you $100 to do your taxes. You know what they are doing when they do your taxes? Adding, subtracting, and algebra. Can all of you add, subtract, and do algebra? Yes. Can I add, subtract, and do algebra? Yes. Should I be paying someone to do my taxes? No. Do I? Yes. Why? Starts with an L, ends with a Y, has AZ in the middle of it. Lazy.
Wait, didn't you talk about saving money?
Yes, I know. But what did I open this whole lecture with? Don't be like me and the majority of Canadians. Be smart.
Exactly, it's smart to pay someone to do your taxes so you don't mess them up.
Jack, here's something a lot of people don't know. Revenue Canada checks your taxes for you. You could send in a blank form, and they would do them.
Boom, like that.
Hey, don't do that.
Why not?
Damn it, it recorded. Don't do that. Did it? All right, here we go. Find the value. I'm looking for the end value, aren't I? Right? So, I want to know, find the value, and then tell me the interest. Go. So, the amount equals my principal, 8,000. 1 plus, what's my rate? 0.092 over what?
7.
Not 7. Over what? 4, because it's quarters. 7 years, but how many times per year? 4. What was my final amount? What? What is it, David? Your calculator does all this work, people. What is it? What's the answer?
15,121.95.
That's the final amount. What is my interest? Interest equals what? No. Interest is the amount you end up with minus your principal, which is, in this case, $7,121.95. Please notice that at a rate of only 9% per year, and there are investments you can find that return that amount of money, this dude doubled his money in 7 years. Did he have to do any work for that? He had to sit on the couch and eat Cheetos. Well, it's hard work for some people.
Yeah, because she just stink.
Does everybody understand? All right, now listen. Listen to me. Everybody follow along. Number 6 and number 7 you can do. Number 8. You cannot do number 8 yet. It will require me to teach you a whole lesson. So, listen please. No number 8 yet. No number 12 yet. Then on page 197. You cannot do 9 and 10 yet. Now, ladies and gentlemen, why am I going so far ahead with this? Because I am not going to be here tomorrow or Thursday. Okay? So please follow along with what you can and cannot do. Number 12, no. 13, no. 15, no. 16, no. 12, 13, 15, 16. 12, no. 13, no. 15, no. 16, no. That is what you are going to do on Thursday. All right? Now listen to me. Class goes for another 11 minutes. I am going to show you right now, and it will be recorded, how to do most of these questions. But it's not something you pick up immediately. It takes a bit of time. So I'm going to show you. It will be recorded. Maybe you'll be able to figure it out. Do not write this down right now. Just watch for a minute. If I have this, 2x equals 10, what do? You do the opposite of what you see, yes? Agreed? If I have if I have 5 equals x squared, what do? 25 equals x squared. What do? Square root. Okay, I would square root both sides. So we're comfortable, right? How do I do this one? You know that's squared, yes? Right? But if you didn't, what's the math you would do there? You would say, oh, okay, well, I guess I'd take the xth root and then the xth root, but I don't... This is not something we're comfortable with, right? Okay. Without going into why it works, because you don't need to know why until next year, this is what you use. You use something called logs. On your calculator, you will see a button that says log. You also will see a button that says ln. Sometimes it's the same button. They're shifts of each other. You don't need to know how they work yet. No, I lie. You don't need to know why they work yet, but how they work is helpful. Please notice, 3 to the 4th is 81. So, look what happens to the base. It becomes the base of the log. Look what happens to the answer. It becomes the thing you are working at. And look what happens to the exponent. It becomes this. So, everybody looking at this, right? That would mean log 5 of what number? 25 would equal what? X. Everybody cool? Everybody understand? Just wait a second. Does everybody follow this? Okay, so this is what is going to happen whenever you need to find an unknown exponent. Okay, I haven't taught you how to use your calculator for this yet. I'm just saying that in order to find unknown exponents, you're going to use this operation. And you can see it's on your calculator. All right? Now, that shouldn't be there. I don't know why that dot's there. Okay? Now, here on your calculator, oops. Okay. On your calculator, the button log works in base 10. All right? So what would the log 10 of 100 be? Without going to your calculator, what's it going to be? 10 squared, right? It's going to be 2. Because 10 squared equals 100. Everyone is cool, right? Everyone's with me? This is just like we do subtraction to fix addition. Addition to fix subtraction, multiply to fix divide, divide to fix multiply, square root to fix square, cube root to fix cubed. Well, we use logs to fix when we have to reverse an exponent. Okay? Or, sorry, when we have to reverse a base because we don't know the exponent. Is everybody good? Everyone's okay? So, if you find yourself with a question like this, and we've seen this right now, correct? If we had 1 plus 0.08 to the x, because I don't know what that is, right? 1,000 to this equals my amount. I gotta do some logs to sort that out. So all those questions that I crossed out, except for the ones with continuous interest, they're another totally different thing. Except for number 9 and 10 that are continuous interest, do as much as you can until you get to this situation where you have something with a blank exponent equals something else. Stop there. And we will fix it on, when do I see you next? Friday. Okay? Everybody understand? So let me show you what I mean. Let's go back to a question that we already know, that we've already done. This one. So let's say right here, and I'm just going to steal it. Let's pretend that we knew our rate, which we did, right? We worked that out. If the question was, how long will it take to earn that money? You would get it to here. All right? And then on Friday, we'll finish this off and show you how to actually find X. Everybody cool? Now, some of you, if you're from another country, you've probably already seen logs, but most of you probably haven't. Okay? Kyle, have you done logs? Kelly, you have? No? Damn! Whose test am I going to use for a key when I forget to make them? Just kidding. Sarah, have you done logs? No? Brazil wins in the log Olympics. All right. So everybody's good? All right. Now wait a second. Let's, no. We're cool. If you can get to there for everything all but the continuous interest questions. If you can get to there, you can stop. Okay? Test tomorrow on trig. Now listen, it is Miss Purvis that will be here. She is a math teacher. You can ask her stuff because she will not say, oh, I don't know, but she knows it's a test, so she's not supposed to actually help you. Understand? Okay.